WHMIS stands for Workplace Hazardous Materials Information System. WHMIS was introduced across Canada in the late 1980s by a combination of federal and provincial legislation. WHMIS was created to reduce injuries, illnesses, and deaths associated with working with hazardous materials in the workplace. The system requires the classification of hazardous materials into one or more of 6 classes and only applies to materials that meet specific hazard criteria that is set out under federal law. These hazardous materials that come under the umbrella of WHMIS are also referred to as controlled products. Any controlled product that is used must be appropriately labeled, must have a corresponding material safety data sheet, or MSDS, and must be used only by people who've been properly trained. This training must not only enable people to recognize class symbols, but just as importantly, it must also give people the ability to read and correctly interpret labels and material safety data sheets. As we have already said, WHMIS requires controlled products to be classified into one or more of 6 classes. These classes are Class A, compressed gas; Class B, flammable and combustible material; Class C, oxidizing material; Class D, poisonous and infectious material; Class E, corrosive material; and Class F, dangerously reactive material. Now, each of these classes is represented by a symbol, with the exception of Class D, which is broken into 3 divisions, and each division has its own symbol. So, we have a total of 8 WHMIS symbols, all of which we need to be familiar with. The first symbol, the symbol for Class A controlled products, looks like this. This symbol must appear on all compressed gas cylinders and simply indicates that the cylinder may contain a gas under pressure. If subjected to heat or severe impact, the cylinder may explode or act as a projectile. The symbol for Class B controlled products, which are materials that are flammable and combustible, looks like this. These are materials that may catch fire if they are exposed to a heat source or to an ignition source, such as a spark or flame. Class B controlled products can be gases, liquids, or solids. Examples include gases such as hydrogen and propane, liquids such as gasoline and kerosene, and solids such as magnesium and potassium. The next symbol is for Class C materials. These are oxidizing materials, and in simple terms, these materials present a fire or explosion risk when near other flammable or combustible materials. They also have potential to cause burns to the skin and eyes. These Class C materials must be stored in designated areas, be kept away from ignition sources, and should only be handled with appropriate personal protective equipment. Examples include nitric acid, hydrogen peroxide, and chlorine. Class D comprises materials that are poisonous and infectious. All the materials in this class must be handled with extreme caution, and safe work practices and procedures must be strictly adhered to. As we have already said, this class is divided into 3 divisions, each with its own hazard symbol. Division 1 is for materials which can cause immediate and serious toxic or poisonous effects and is represented by the universally recognizable skull and crossbones. A single exposure to any of the materials in this division can be fatal. Examples include sodium cyanide, carbon monoxide, and sulfuric acid. Division 2 is for materials that have toxic or poisonous effects, but not effects that are immediately life-threatening. Repeated exposures to these materials may, however, lead to death or permanent health damage. Skin irritations, allergic reactions, organ damage, and cancer are all possible outcomes from exposure to these materials. Examples include benzene, asbestos, lead, and mercury. Division 3 is for materials that are biohazardous and infectious. A biohazardous infectious material is a material that contains organisms which can cause disease. Included in this division are viruses and bacteria. The effects of a single exposure to these materials could result in a serious illness or disease which may ultimately be fatal. A good example would be a contaminated blood sample containing the hepatitis B virus. Class E are corrosive materials and are represented by this symbol, which clearly indicates they can corrode metals and cause serious injuries to body tissues. Inhalation of vapors from corrosive liquids or the inhalation of corrosive gases can cause respiratory system damage. Included in this class are such materials as sulfuric acid, sodium hydroxide, and ammonia. Class F is for dangerously reactive materials and uses this symbol. These materials can react violently if exposed to water or different energy sources such as light, heat, vibration, and extreme temperature. The results can include fire and explosion and/or the release of toxic gas. Examples include styrene and benzoyl peroxide. It is important to be able to recognize all of the 8 symbols we have just looked at and the hazards they represent, as at least one of them will appear on every WHMIS supplier label. The containers of controlled products must be labeled to clearly indicate and identify the contents and the hazards of the material. A WHMIS label can vary from a mark or sign to a sticker or wrapper. The label can be attached, imprinted, stenciled, or embossed on the controlled product itself or its container. In the workplace, there are 2 different types of WHMIS labels used most often that you should be aware of. They are the supplier label and the workplace label. The supplier label, an example of which you can see here, is on the product when it is received on site. It must contain the following information: the name of the product, the name of the company that supplied it, a reference to a material safety data sheet, the hazard symbol or symbols, the risk phrases, which are words that describe the main hazards of the product, the precautionary measures, which is how to work with the product safely, and the first aid measures, that is, what to do in an emergency. The text must be in English and French, and finally, the label must have a distinctive WHMIS border. The other common WHMIS label is the workplace label. It must appear on all controlled products manufactured in the workplace and on controlled products that are transferred from the supplier's container to a worksite container. This label can also be used to replace a supplier label that has been damaged or is no longer legible. A workplace label must have at least the following information: the name of the product, information for the safe handling of the product, and a reference to a material safety data sheet. It is important to note that in a few special cases, any form of clear identification, such as the name of the product or a color code or numbering system, may be used instead of a workplace label. These cases include controlled products in pipes, reaction vessels, ore cars, and on conveyor belts. They also include products that are transferred into worksite containers for use by one person only and are used up during the shift on which the container was filled. A material safety data sheet must be available on site for every controlled product that is either used or produced at that location. These material safety data sheets must be readily accessible by everyone. Typically, an MSDS is made up of at least 9 sections. The following sample form shows the 9 required sections that must be present, although not necessarily in the order shown. The first section contains product information. It includes the name of the product, the manufacturer's and supplier's names, their addresses, and emergency phone numbers. Section 2 details the hazardous ingredients and describes the chemical composition of the product and the concentration of each chemical. The third section is the physical data and covers such things as whether the controlled product is a solid, liquid, or gas, and what it smells and looks like. Section 4 indicates the fire and explosion data, such as how flammable the substance is and the explosive properties of the material. Section 5 records the reactivity data, such as the chemical instability of the product and the substances it may react with. The 6th section covers the toxicological properties, that is, the health hazard data, such as the routes of entry into the body, the exposure limits, and the effects of being exposed to the product. Section 7, the preventative measures, include the safe handling, use, storage, and disposal of the product, and what personal protective equipment is required to handle it. The 8th section covers the first aid measures, which include what to do in the case of an emergency involving the product, such as a poisoning or direct contact with the substance, and the final section, which is the part that includes the preparation information. This section identifies who is responsible for preparing the MSDS and the date it was prepared. A material safety data sheet can often be quite a complicated and demanding document that requires an understanding of many physical and chemical terms and concepts. If you are unsure about any of the information contained in an MSDS that is applicable to your work, make sure you discuss it with the appropriate person in your organization. A fire or explosion is one of only 3 ways that we can become injured or ill when dealing with controlled products. The other 2 ways are by having direct physical contact with controlled products and by having controlled products actually entering the body. Direct physical contact means contact with the skin, face, or eyes. This contact can occur with a controlled product in any physical form, be it a solid, liquid, or a gas. Direct physical contact will obviously not necessarily lead to harmful effects, but can result in a variety of problems, including burns, tissue damage, dermatitis, and allergic reactions. The wearing of appropriate personal protective equipment, such as full-face shields, gloves, aprons, and boots, is often required when the possibility of direct physical contact exists. The most common problem, and frequently the most serious when using controlled products in the workplace, is when the products actually enter the body. And this can only occur in one of 4 ways. By absorption of the substance through the skin, by injection of the substance, most commonly via a needle, by ingestion, most frequently as a result of bad hygiene and contaminated food, and finally by simply breathing in the substance. Of these 4 ways, inhalation is by far the most common route of entry into the body. Dust, vapors, mists, sprays, smoke, fumes, and gases could all be potential sources for controlled products to enter the body. Adequate ventilation and/or the requirement to wear appropriate respiratory equipment are the 2 most frequently used methods of controlling airborne contaminants. The Workplace Hazardous Materials Information System that we have just looked at is just that. It is an information system. It supplies us with access to knowledge about controlled products that we use. It does not in itself mean that these substances will be used safely. Fortunately, most job tasks in the workplace that require the use of controlled products also have established safe work procedures in place. Following these procedures is the best way we can avoid accidents, injuries, and illnesses associated with the use of hazardous materials. And remember, it could be argued there is no such thing as a safe chemical, but it would be hard to argue that there is not a safe way of handling and using all chemicals.